Thank you very much, everyone. I'll take one of my hats off for now. Thank you very much for coming. So yeah, I'm talking today about dashes all the way down. So now the first thing I'm going to warn you is I will be talking quite quickly. I'm sorry for that, but I've got a lot of stuff to cram in, and hopefully I won't go over time. So I need to really keep a move on. And I'm happy to answer questions at the end or in the break if you need to come get me. So the talk's basically in three parts. I've got the introduction to give you a quick overview of what I'm going to be covering. I've got a demo, which I will pray to the demo gods will work because I only finished it at 10 o'clock last night, but we'll see how we go. Let's tempt fate. And then I'll have some summary and closing thoughts and remarks and try and give you a bit of a rundown on what I've covered in the two previous parts of the talk. And possibly a few kind of slightly controversial takes on what I'll be talking about today. Now, first thing I want to do is say a big thank you to Sasa Europe, whose talk, the Soul of Erlang and Elixir, is actually the primary inspiration for this talk. And really, my talk is a remix, a cover of his talk, but just in the context of Dart and Flutter versus Erlang and Elixir. So I really recommend, if you get a chance to, not now after my talk, hop onto YouTube and have a watch of his talk, because he's a fantastic presenter, way better than I am, and his talk is just awesome. So it really was the thing that inspired me to do this. Now, today I'll be talking about software systems. And before I start talking about them, I should say what I think I mean by software systems. And what I'm talking about is probably well explained by a quote from his video, where he calls them a system where you're running different, mostly mutually unrelated activities in the same system. So a concrete example of that, because that's kind of vague, is basically a backend system that you might need for your average mobile Flutter app. So most apps these days want to talk to a backend system for various services, authentication, data, so forth. So that's the kind of system where you're doing different kinds of things for different clients, and they're not related. Like my client is not necessarily related to your client, or like my sign-in should not be related to someone else's sign-in on the same system. So for software systems, I think there's a few kind of key requirements, the things that I expect to have in the system to let me run it properly. Observability, to be able to see what's going on within the system, so not a complete black box. Fault isolation and tolerance. Some part of the system breaking or inevitable bugs happening shouldn't affect the rest of the system. They should not, one small bug somewhere in one corner of the system shouldn't take the whole thing down, or shouldn't adversely impact a whole range of users of this, or clients of the system. Similarly, the system should remain available, potentially at the cost of task latency. What I mean by task latency is that the system as a whole should keep moving, even though it might not be the most efficient at serving each and every request or task that it's given by its clients. So we pay the cost of perhaps not being as quick or as low latency as we might be, but at the benefit of having a system that remains available for all tasks, all users. And finally, operational control. We want to maintain control of the system. We do not want to be essentially locked out of the system or lose control of what the system is doing at any one time. Now, hopefully these aren't too controversial, but that's just basically my thoughts on what we want as requirements of a software system. So how does Dart fit into this picture? Well, I think Dart's isolates are a very underappreciated part of Dart, and really can help bring all those pieces of functionality, all those requirements that I just mentioned, to our software systems if we use Dart to build them. And isolates, for those of you who aren't aware, are basically Dart's version of the actor model. They're an implementation of the actor computing model. Now, for those of you who don't know what the actor model is, this is what Wikipedia has to say on it. I've condensed it down, it's a very long article, but essentially it comes down to concurrent computation being done by actors, and actors as the basic building blocks of the system. Now, actors respond to messages They do things, basically business logic. They carry out actions based on those messages. They make decisions. They can create more actors, and they can send messages on to other actors. And the key thing there, because I get said messages a number of times, is that actors only interact via message passing. They don't directly interact with each other. They send messages to each other. Now, in terms of Dart's isolates, or Dart's actors, but we'll call them isolates because that's the name that Dart gives them, they're essentially completely self-contained pieces of processing. So they've got their own stack, they've got their own event loop. They're essentially completely self-contained programs that are running concurrently. And just like the actor model says, and like the name says, isolate, they are completely isolated from each other. So they don't share any memory. So how do they communicate? Well, we have a facility in Dart called receive ports and send ports. They're essentially like a pair. One's linked to the other. And that is the only way isolates can communicate between each other. They send messages in an asynchronous fashion, not synchronous, asynchronous fashion. They send those messages, and then those messages are received by the other isolate, from isolate A to B or B to A, also in an asynchronous manner. So they're not even tied to each other in terms of synchronous communications. The communications are asynchronous. Now, this does lead to some misunderstandings, especially because Dart's a system that, or a language that a lot of people come to from somewhere else. Maybe they come from native mobile, from web development, from backend development, like all kinds of places. People tend to come to Dart as not their first language, and Flutter is not their first framework. So I think I should, cover a few of the common FAQs about Dart isolates, because even though they're great, it's not all a bed of roses. So first thing is, a lot of people talk about isolates as if they're like a placeholder for the word thread. Isolates are not threads. Isolates are run by threads, but there is only a thread pool. So it is not it does not have to be a one-to-one from threads to isolates. That is not the case. A thread is not just another, an isolate is not just another name for a thread. Threads execute isolates. Now, the other thing is that a consequence of this is that there is not an infinite number of threads to run an infinite number of isolates. Like, you can have way more isolates, and I'll get to this in a moment, than you have threads, because in fact what Dart does, what the Dart virtual machine does, is create a pool of threads that are responsible for running all isolates. So isolates are exactly what the actor model says they are. They're actors, but it's the threads that actually give life, if you like, to those isolates. And there's a limited number of threads in the thread pool. More on that in a little bit. And as I said, they're completely isolated, so no shared memory. Globals, like that you might be used to, that it's a global variable supposedly global to the entire program, that is not the case with isolates. A global in one isolate is not the same global in another isolate. If you have the global variable A in isolate A, it is not the same variable as global A in isolate B. They are completely separate pieces of memory. And as I mentioned, asynchronous message passing only, that's the only way it happens. Now, an important, more like an implementation performance aspect is that garbage collection is, however, shared across isolates. This is not the case in all implementations of actor models. For instance, Erlang does not do this. Erlang separates garbage collection across its version of isolates, which are called actors called processes. So this isn't something particular to Dart. It has a few unfortunate side effects. It has a few fortunate side effects, but that's just something to keep in mind, that garbage collection does happen across all the isolates. They are not, even though they don't share memory, they do share a single garbage collector. So it can impact, the garbage collection in one isolate can impact performance in other isolates. So that's all a bunch of theory and big talking and fast talking, but it's probably going to make more sense if I show you an example. So let's say we've come up with this fantastic new service called sums.com. We've got the VCs on board with heaps of money being thrown at us to build this system. And what we're going to do is provide this awesome service where we will have a system where clients can connect via a WebSocket and request the sum of a set of numbers, a set of natural numbers, in this case from 1 to 3, and they will get 6 back. A super useful service. I'm sure we're going to have a huge number of clients. We're going to be all very wealthy, IPO to lots of money and everything. But we better build this system before we get too far ahead of ourselves. So let me show you this, how we're going to do that. So here I have something I built earlier. Hopefully, can you all read that? Is that big enough, the font? So what I've got is, oops, let's just bow to the demo gods and cross our fingers. Here is one first example of why Dart, I think, makes a good language and a good ecosystem for this sort of thing. I've got my whole system built as a single executable standalone. It's not linked to any other shared libraries. So basically, I could take this executable I built. I happen to be on a Linux machine. I could deploy it to any other Linux machine in the cloud, in a Docker container. It's just going to run. It doesn't need any dependencies, and it's just a one-line command. It's not a whole bunch of make files or build scripts. It's just one command line: Dart compile exe and the name of my Dart file entry point, and I've got an executable which I can run. And the other thing is that this executable is not just like some interpreter bundled in with my Dart code. This is native, in my case, x86 code compiled for Linux. So here it is running. And what I've chosen to do is to actually bundle the front end that I'm going to use for this web service, it's just a WebSocket, as a web app built in Flutter, just to really make things a little bit exotic. Here it is. So this, again, makes deployment easy. All I've got is just a bunch of HTML and assets that I can put anywhere, and it's actually being served by the same executable that's doing my web service. So what I've got is here 3 tabs, basically. The user interface, this is basically what the users will see. But for the sake of the demo, I'll put everything together. So I've also got basically a dashboard here of some stats. You've got the memory usage, a huge 8 megabytes. So it's not like an Electron app that's suddenly taken up a couple gig of your memory. It's 8 meg currently. And this is how many successful completions. I'll talk about what that is in a second. It's basically how many how many tasks are being done per second. Finally, I've got like a command line, a REPL interface into my app, which I'll demonstrate what that's for shortly. So as I said, it's this wonderful service where we can submit a number from, say, 1 to 42, and it gives us back the sum of all the numbers through to that number. So like any system, though, we're not immune to vagaries of human development, hence bugs creep in, strange behaviors turn up. So in this case, the lucky number 13 represents an error case. Now, in most systems, you probably have some sort of, or you might put in some sort of try-catch, like at a low level at the very top, where you catch any errors that bubble up from your code. So in this case, you might have put some try block somewhere to catch these errors and return an error message to the user, because we don't want the operation just to hang or to not return anything. In this case, I haven't done that. I haven't needed to, because all I had to do was essentially listen to the isolate that I create to service each operation that comes in. And if the isolate exits incorrectly, per my predetermined behavior of, i.e., it did not return a natural number, which represents the sum that we want, I can listen for those events and do something about them. In this case, I just return the string error to say something went wrong. Now, this doesn't mean, though, that the system is no longer operable for anyone else. Any other user can come along and submit a request, and they'll get back a response. Now, while that error case could be handled with a try-catch situation, there are other errors that could come along that you can't try-catch your way out of. So for instance, what if some user decides 3, 4, 5, 6, 7, oops, yeah, let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Decides 9 nines is a good input for our system. Well, in this case, the system tells us, it's calculating, but not so responsive. Okay, a bit of a problem. Other users come along though, or maybe the same user decides to try to submit something else. still get a response back. So the system's still responsive. Now, to make sure that we're like, I'm not cooking the books, not fiddling things, even for a demo, let's just say we want to make the system a bit more realistic. And what I'll do is I've got some some load testing code, which can spin up essentially the equivalent of 10,000 concurrent user requests coming into the system. But I want to make sure that things are not realistic. Okay, I can't say this is realistic, but let's just try and pretend to be a bit more real world. So what we'll do is we'll respond to those within 1 second. So if I spin up 10,000 of these workers, what I'm doing is basically getting my load manager to start firing off 10,000 of these sum requests to create some load for the system. And it's then having to return the result every second and rinse and repeat over and over again. So basically 10,000 concurrent operations every second, so that we now have 10,000 isolates. Don't have 10,000 threads, 10,000 isolates running this operation, returning the result to another isolate, which then sends the results back to this dashboard, because this dashboard is, again, just another WebSocket that I've got open, connected to my system, showing me the results. So you were seeing, like, it's jumping around a bit, probably because of garbage collection, because as you can see, the memory usage has now gone seriously up. We're at about peaking at 2.5 gigabytes, but we're servicing 10,000 concurrent connections every second. I'm pretty sure most backends do not have 10,000 concurrent users. Well, maybe in bigger systems, but in Australia, that's a fairly big user base. It's not like, all your users are going to be submitting a request unless they're all bots. And you can see the completions are pretty good. They're wavering a bit, but they're around 10,000. However, what we can see is our calculation's still happening. So even though our system's still responsive, it's still able to complete work for 10,000 other users, our existing bug has basically stopped responding to one of our users. That response still hasn't come back. So clearly there's a problem. So now I am going to put not my Android hat on, but my DevOps hat on. And maybe I got an alert saying our response times have gone down. Maybe there's some monitoring saying, as you can see, the CPU load has spiked. Like, there's some alert that I've got saying, hey, something's wrong. Because if this keeps happening, like I mentioned, there's a thread pool. So clearly something's gone wrong, and we're now tying up one of those threads because it's never responded. It's still processing this operation. And if we keep letting that happen, soon our system will eventually slow to a crawl and lock up potentially. So it's not infallible. So what I'll do is I will go to this third panel, which is my backend, like my DevOps little REPL, like command line interface into it. And I will say list, and I'll use my cheat sheet because since it's a demo, I feel a little bit under pressure. So I'll just double check, okay, even though it's my own system, I will get a list of all the processes running on the system. Hopefully. Yes, there we go. So there's all the processes. They each have a numeric ID. However, this doesn't really help me. Like, somewhere in this, I'm just going to pretend that I don't know, because of course I do know what the real reason is that the problem's happening. But as a DevOps guy, maybe someone else checked in the code. What on earth's going on? There's all these processes. Somewhere in that needle in a haystack is the offender. So now I've got a suspicion that it's something to do with processing time, or maybe something's taking too long to process, or is requiring too many resources. So what I have is another command that I can run. And these commands are essentially pre-built by me, but this is essentially executing dark code down the bottom here in a simplified form. So I've got another command, psload, which will give me a list of the amount of operations or the load that each isolate is handling, to see if I can work out what's going on. Oh, is it wrong? Oh dear. Okay, this is where the demo gods might be getting me. Oh, yes. All right. Now, it would help if I provided, I may have mucked things up because I didn't provide. So I forgot that the PS load function actually requires like a limit of how many things it should return. I'll see if this helps or if I've mucked things up. Or I think I've mucked things up because I took some shortcuts last night to get things working. So bear with me for 1 second. I'll just restart the system. Clearly, this is not a great demo of a robust system, but like I said, like I did sort of not do the usual work ethic of getting things finished before 10 o'clock at night. So let's just see, are we back running? Yes, okay. So let's set up a calculation. All right, now let's do those 10,000 jobs again. Yep, up they come. All right, and I'll just skip to running the PS load. So let's have a look here. So let's have a look. It's still, not responsive, but these, we're servicing quite a few already. All right, let's get back into it. And okay, so here we've got a list. Like I haven't actually, like normally what you'd want to do is sort this. For instance, if I'm looking for something that's taking too much time to respond, I'd sort like the number of operations, in this case, per isolate, and I'd sort it based on like highest to lowest. But in this case, it just so happens that I started, just for the purpose of the demo, I started like the thing that's taking up the most by a way, way big margin. And it's in the top 10 of the results. So you can see like isolate ID 1 happens to have like basically 5 orders of magnitude, or even more, way more operations processed than all the others. So clearly it's the problem child. So amongst those 10,000 processes that we've got in the system, I'm able to identify the problematic one. And the other thing is, like when I talked about keeping control of the system, we should be able to maintain control of the system. In this case, we know now what's causing the problem, but I need to be able to get control of the system and get rid of that problematic operation. So if I just run stop on that with that ID, we should see that, yes, our operation has finished and it's returned like an error. It didn't silently die. It told the user what happened. Yeah, after a while, something went wrong and an error happened. Now, if we go to the code, so I'll get rid of, that's my cheat sheet. Let's have a look and see the actual code that's powering our fantastic service. You can see it's very complicated here. So first of all, while we're here, I can see immediately there's the problem. There's our 13 bug solved. No more bug. So now we should be able to be fine with the magic number 13. Similarly here, I can see, wow, this is a super inefficient way to calculate a sum of numbers. What if we use high school maths and instead calculate that sum using our old friend here and save that. And so now, if I go back to my system, we can see 13, no longer a problem. And now, even if we do a huge number of 9s, fast as grease lightning, no problem. So here we were able to make changes to the system while, don't forget, we're still servicing 10,000 other requests per second. So We've maintained control of the system. The system, even having holes plugging into it, has sailed on, not sunk, even while we've been able to fix the problems, all the while keeping it up and running without taking the system down. Yeah, I better hurry because I only have 5 minutes left. So, oops, not Zoom. Oh, yes, back to our slideshow. So when I said it was dashed all the way down, I fibbed a little bit because Dart has some problems doing everything I just showed you. There's no hot reloading when you build an ahead of time executable, for example. So you can't do the same hot reloading like I just showed you that we get with Flutter. It's hard to introspect because the debugger is not available. Like you can't just get that list of isolates like I just did in an easy manner, because in ahead of time compiled executables, there's no VM service which provides the debugging. There's no preemptive scheduling. So that example I showed you where one of the isolates basically locked up, that would eventually lock up the entire system if we used only Dart. And there's a 16 thread limit is that thread pool that I mentioned. So what I did was I used a project called Apollo VM, which provides a virtual machine running Dart inside Dart, built with Dart. Well, that's a mouthful. But it means I can reload those scripts at runtime like you saw me do, like we do with our Flutter apps, and keep the whole system running. No state is lost because each script is running in its own isolate. Likewise, I could patch Apollo VM to add preemptive scheduling, which meant like even that example I showed you, even if actually I fibbed because I could have actually done 16 of those, and while the system would have ground to a very slow crawl, it wouldn't have stopped responding. And similarly, I haven't done this yet, but I've done it with Lua, is patch Apollo VM to provide stack traces of running code. So even though it was easy for me to spot that error just before, if it was a much more complicated, realistic system, I could get a stack trace of that isolate that was locked up in an infinite loop, essentially, and find where it was happening, because I could see a stack trace of it running, even though it was completely CPU bound. Now, the problems with the Apollo VM are that it's a tree walker. It's not actually a virtual machine, which means it's very, very slow, as you saw with that calculation, and it uses a huge memory use. It has a huge memory usage. Compared to Lua, which I initially did a proof of concept of this for, it's 1 or 2 orders of magnitude slower, and it's 2 or 3 times more memory use than, say, Lua was, which is a virtual machine interpreter, which is way more efficient. Now, the good news is, though, that while we could redo Apollo VM to be an actual VM interpreter, a better solution is just around the corner, because WebAssembly support for Dart is here, and it's almost available in production for production use. It's still marked experimental, but it's getting very close to being ready. So very soon, instead of using Apollo VM, I will be able to use, or anyone will be able to use a WebAssembly engine to power that same scripting functionality, and because Dart already has this experimental, soon-to-be production support of compiling Dart into WebAssembly, we could basically host Dart compiled into WebAssembly inside an actual Dart virtual machine running, which is a bit of inception, but it means we will get all this functionality that I just showed you. Now, the final question is, why are we doing this in my last minute? Well, it's a lot of heartache. So why is it worth it? Well, to me, and this is Saza's slide as well, so to him as well, uniformity is the huge benefit. We've got simpler development because as Flutter developers, we are also building our backend in Dart. So it's a single language, single set of packages and ecosystem that we're using. Simpler testing, we're only testing in one language, we're using the same testing tools to test our backend and front end. Way simpler deployment. I showed you, it's a single executable. It's way simpler than having to roll out like a separate web server, a separate like front-end load balancer, all kinds of things, or having to run a huge build system just to build your application. Simpler maintenance, because we're just keeping things consistent. There's only one tech stack we have to learn, and improved collaboration, again, because of one tech stack, one language, one set of libraries. That means a junior coming onto this project has a way smaller learning curve, has much less to get up to speed with than if they had to learn, say, Nginx. They had to learn TypeScript and JavaScript for the back end. They might have to learn SQL for the database. Everything can basically be in the one tech stack. It makes it so much easier. And with that, I've run out of time and got to my last slide. So thank you very much, and I'm happy to take questions later.
So we just have 5 minutes. We can do questions as well as there would be another talk just starting at 11:25 in the other room. This room would be doing a Flutter talk, and the other one would be doing a talk on serverless. So if you'd like to change rooms and ask questions, now is the time. So any questions?
I think I stunned everyone into silence. So
Just
that's right. But you can all come and catch me during the lunch break or later at drinks and quiz me like in a much more private setting or berate me in a much more private setting.
I do have a hard one for you, Max.
Oh, sure.
If you weren't using Flutter for your front end,
yes,
would you still recommend using Dart for your back end?
Well, no, because like the key driver is uniformity. So if you're building, say, an app with Android, Compose, and Kotlin, I'd recommend using Kotlin because very shortly, Kotlin will also have the same WebAssembly support or target support as Dart. The only thing is that Kotlin multi-platform does not have isolates built in. Coroutines are definitely not equivalent to isolates. So you would have to implement the functionality that isolates give you, which is possible, but you have to implement yourself in Kotlin. But it's definitely possible in Kotlin multi-platform. You just have to do more of it yourself.
Do you love semicolon? Uncoded.
So
Do you love semicolon uncoded?
I'm sorry, I couldn't.
Semicolon.
Semicolons. Oh, that's a really personal question. But let's say I've learned to live with semicolons.